So my test is looking at thin film collagen gels, working out how tumours grow and what factors influence it. And for that you need to input values of the tumour stiffness around the tumour cells, the collagen matrix. And after looking, there really weren't any good values out there. There were some for tensile testing, but that isn't really applicable. And also, it's been shown that at different kind of speeds, the stiffness is changed. Really interesting part of this research is the fact that it hasn't really quite been shown before that you can do thin film indentation testing using a mechanical testing machine. Before, it's been either you have to use really, really small nano machines, or you have to use kind of single testing glass beads. The electropulse is able to give you a complete indentation all the way through, providing lots of information at a very precise scale. So it means that you get a better understanding of what's actually happening, whether there is relaxation, whether you're looking at something that is deforming plastically or elastically. We were using a 5 Newton load cell, which was great. I mean, the level of detail you were able to get down to approached micronewton level, so that was allowed to be doing the testing that we were able to do. It's amazing the fact that you can take off a 5 Newton load cell and on the same machine test a 3000 Newton load cell. It's ridiculous, because my friend was doing testing with just massive machines and mine's so sensitive. But the Instron, the company, was amazing to look around, especially going to walk around the factories. You can see just the scale of things, from producing the tiny mini E1000s to the massive, huge machines. And I think it was amazing to see just the depth of, well, how much this company does. So I think Wave Matrix is a great tool because it is somewhat intuitive to learn in the fact that each block gives you a kind of visual representation of what you're doing, such that you can just see the entire test and check everything through. I mean, I'd never really used it before, and I was able to use it for a basic test within an hour. So it does the job very well, and it allows you to make every single setting different. It's nice that you don't need to know everything to do your tests, but there's always more to learn and there's always more to kind of improve upon. We've been shown you're able to get some mechanical values, and we've shown that there is some reliability, but I think increasing and honing this technique will be really useful, especially the fact that you can see a multiple static push through, whereas before people just basically placed glass beads and used a microscope, and you don't really get an understanding of how the tissue changes. It also allows you, I think, to be able to explore the viscoelastic effects, because that's something you can do. You can see the relaxation of creep style tests. So I think there is a lot of use for this electropulse in the future in this area of research. I think being able to work with Instron has really been able to help my project, because there is so much you can do, especially with a machine, and I was able to have so much help that I was able to improve my tests, because the people here know so much, and UCL knows so much about the research, but the actual mechanical testing machine, they know less about. I mean, I know I've learned a lot that my supervisors didn't learn about the machine, and I'll be able to bring that back to UCL for being able to testing in the future.